Hi there and welcome to the AbsInt Videocast for the October release in 22. My name is Christian Humbert and I'm glad to present you the latest features of this release for our binary level analyzers, aiT, StackAnalyzer, the TimeWeaver, ValueAnalyzer and the TimingProfiler tool. As usual, let's have a quick overview on our release video today. First, I'd like to start with an overview of the new features in the graphical user interface, followed by a decoding update. Then I'd like to show a new feature, a new option actually in the aiT worst case execution time analyzer, the so-called contradiction finder. I have new options and new features of the TimeWeaver for you today. And I'd like to conclude the presentation with some new AIS2 specifications. All right, let's get started with the graphical user interface and the decoder. In my first demo, I'd like to work with our well-known scenarios example. I have it here in a configuration where two of these tasks, the 1 millisecond and the 5 millisecond task, are running on core 0 in their own configuration, by the way, and the 10 millisecond task and the 2 interrupts routine running in a separate core 1 configuration. All right, so far. Let's start with the 1 millisecond task analysis. I'm running them here. There is no message, no problem occurring here. As you know, we have these annotation markers in the graph, right? The orange arrows where you can directly jump to a specification in the AIS file. These were already available also in the disassembly view. You know, if you click here on that button, you jump to the disassembly, and there you'll find these markers as well. Now, with the new release, we introduced that also message markers are shown in the disassembly view. For that, I'd like to force the analyzer producing some messages here. Let me just quickly uncomment the recursion annotations to force to get a warning. And if I repeat the analysis, we will get a warning. And if we now jump to the disassembly, you will also find that one. Let me just repeat it again. To find the location here, you will also find a message marker for problems occurring during analysis also in the disassembly. The next new thing is a new button actually to jump directly to a configuration which is associated to an analysis. So I already mentioned that the 1 millisecond task here and the 5 millisecond task, well, they are grouped together in a core 0 group, but they are also using a configuration that is named core 0, right? While the 10 millisecond task and the interrupts are running in a core 1 configuration. Now, if you want to modify some configuration directly, you previously had to go to the settings, for instance here on the hardware, select the correct configuration and then do your modification. And assume you have several, many of these configurations. It's quite hard to find the correct one which you would like to edit. So this time, with the new release, you can go to your analysis where you know to change the configuration for. There is a new button, this one here, that edits or jumps to the settings field for the selected configuration. So this is a nice shortcut, and if you click there, you see we are now automatically in the core 1 configuration, and we can change here, for instance, a specific configuration, like using the CSA for core 1 configuration, right? Okay, and if I now redo that, then it will of course be applied here to the core 1, which is also taken for other analysis here. The next new thing is just a tiny update, but I'd like to take the opportunity to encourage you to send us always a support archive if you have a technical support question. To do so, you can go via help, create support archive, and now with the new release, not just the AS files, the executable, and the project file will be included in the support archive, but also a workspace file that shows us directly what was your latest or your last stage in your project. The next one is an improvement for the stack pointer guessing in the decoder, actually. So, if you do not provide an initial stack pointer address here in the configuration, then the analyzer tries to guess one based on the symbol table information. So let's track what it does here in this case. So the 5 millisecond task, if you unfold the control flow and stack usage analysis stage, we see that we have guessed a user stack pointer of this address D00035D8. And this, let's check, in the symbol table corresponds, I guess, to the the end address of the user stack area. That's exactly the start address here plus the size of this symbol here. Then we end up with the selected or guessed stack pointer. It's not too bad actually in this example, but now it might be helpful to specify a stack area anyway in the configuration, and you can do that. Let's simulate that. Go here to our new button, to the core 0 configuration directly. We could say let's spend just half of the stack area that is available in this application. So we start with use stack, and we go to, well, use stack, missed 2 lines here, plus, and not the 0x400 to the end, but let's just take the half of it, right? Let's put a bracket here around to have a nice expression. Okay. If we now restart the analysis, then the stack area is applied. You see it here from 31D8 to 33D8, actually, just half of it. But you also see that the guest user stack pointer now has changed. And this is now improved that for the case, if you provide a stack area definition, then it takes the first stack pointer, an initial, meaningful initial stack pointer at the end of the specified stack area. Yeah. In this case, 16 bytes aligned. With the October release, we introduce a new option to find contradictions in the worst case execution time path. Well, if this option is set in a timing analysis, like in aiT, but also in TimingProfiler actually, then we perform an additional analysis step at the end of the timing analysis, and this additional step is basically a value analysis under the hypothesis that really only the computed worst case path can be executed. So basically all variable values leading to a certain path execution are restricted. And if this value analysis then finds that the worst case path is infeasible, then this means the path is somewhat overestimated and can be reduced by suitable annotations. And that contradiction finder also provides hints where the contradiction occurs. So this new feature, it helps to generally improve the predicted worst case execution time and to select a more precise worst case path. Let's have a Before we come to the analyzer, let me quickly introduce the example application here. So here on C code, actually, because it's easier to understand, I guess. So first of all, we are declaring here a sensor variable which is volatile. So it can basically bring back any value of that type range. Then we have a trivial function, which is just returning the parameter value. And we have a more expensive function with respect to the timing, which just sums up all values from 0 to n to the resulting value here. Then there is a process sensor function that provides the threshold back. So if the sensor was smaller, the value was smaller equal than 64, well, it provides the threshold 64. If it was smaller equal 128, it provides 128. Else it provides 255. Okay, and now comes the main function. That's the one we are interested in the analysis. So this code has been auto-generated, and you see we first cache the threshold value into a local variable v, and if that threshold value was 64, we do some more expensive computation here, otherwise some trivial computation. Then we have another if that v was exactly 128, then we also do some expensive computation, otherwise some trivial add. And last but not least, if it was neither 64 nor 128, the value, then we just increase the output by 1. Well, of course, this code structure here is suboptimal, right? Because these three cases here are, of course, mutually exclusive to each other. And if you enter that then case here, you wouldn't enter this one or this one. Yeah. But considering that a static analysis typically has incomplete information, and especially here in the case that we do not know about the concrete sensor, well, after calling the process sensor, the v can be either 64 or 128 or 255, right? And since the analyzer does not know the concrete value, it will consider to enter this branch, this one, and this one in the worst case, which is heavily overestimating, of course. Let's have a look to the analysis itself. So here I have my main analysis, and if I start it, then we see exactly what I described. If I enter the main function, we call the process sensor first, and this process sensor first returns a value, and this value, well, we can check that, is given via register D2. This returned value is either, well, 64, 128, or 255. For the analysis, this is a set of 3 possible values now. So that means we come to that point where we check the value to be 64. Well, yes, we've seen it's contained in that set of possible values. So let's enter, in the worst case, the path calling the expensive function, of course, right? So, but then we come to the next if statement, and here again we check the value of v, and well, it's still contained in our set of 3 possible values. So for the analyzer, it makes perfectly sense to select then again the path going through that expensive function. And last but not least, we have here this check if the value is not equal to 64 and not equal to 128. So basically that would be the case for the 255. And yes, we'll take that as well here and increase the output by 1. So this is of course an overestimated path, right? And we ended up with 18.674 microseconds here. Well, now let's use our new option, the contradiction finder. This can be found here under setup, timing analysis in the path analysis section. If you check that one and restart the analysis again, then you see that a contradiction was found, obviously. The entire problem gets infeasible. We also get a warning where the first time a contradiction occurs. And but you also see that here by the different gray colors. So if you unfold the entry function, we make that here smaller, you see that here after the first conditional branch, both blocks get dark gray, so that means the actual problem is hidden here in that check. And the reason for that is that in the routine process sensor, there was already a path selected for the worst case, and this path corresponds to a special sensor value. Well, let me check quickly, go back to the original situation to show you that. So here we start at main, there's no big alternative, but then we have to process the sensor. And inside of the routine process sensor, the path analysis is selected to go over this branch here. I mean, the sensor value is completely unknown to the static analysis. No? That's because of the incompleteness. But the path analysis has selected this one here to be the worst case path. And this path corresponds to a sensor value which is lying between 64 and 128 actually. But now with the contradiction finder option, when we select that new option, then all variables that are correspond for with this path here will be restricted to the value. That means actually the return value of the process sensor is no longer this 3 value set consisting of 64, 128, and 255. No, if we select that option and re-perform the analysis, then you will see that the return value of the process sensor, which is given by the D2 register actually, is now just one value, namely the 128. That's the value corresponding to our worst case path in the process sensor. But then, if we have this 128 only in the D2, while still having the worst case path going over here, this, which corresponds to the 64 actually, remember this was code here, then this is a contradiction, right? And this is exactly what this new option brings as an advantage. It shows us locations where obviously are contradictions. The next step is to introduce a suitable annotation to resolve that contradiction also. And but this is typically the more challenging part because it requires a manual annotation. In this case, it would help to introduce a value partitioning annotation. So typically value partitionings or trace partitionings can help to resolve contradictions in the worst case path selection. Yeah. Well, in this case, we could, for instance, say that when we return from process sensor, we would like not just have one context with these 3 optional values. We could spend 3 different contexts, 3 separate contexts, where we have 1 times 64 and 128 and 255. And that means the analyzer will perform the remaining part of the analysis after returning from process sensor in these 3 different contexts and will select the one leading to the overall worst case. Okay, let's do that. So let's go to the AIS file. We say instruction main. Well, we take the first call of our process sensor function. That's the call instruction actually, and we would like to go to the next one when we returned from that call. So we can say here one instruction further. Here we would like to start a partitioning. And we would start that partitioning for the register D2, which is the return register, right? So let's, let's take that one. And what do we want to partition over? Well, over the value 64, 128, and, well, 255, for instance, or we can also omit, then it will take all other values except for 64 and 128. Okay, then before we re-perform the analysis again, let's disable the check again and, well, redo the analysis. And, well, first of all, we see our result has heavily been improved, namely from 18 down to 12 microseconds. And you see also now calls to trivial are part of the worst case path. And if we enter the main, we see what happened. After return of process sensor, the analyzer now selected obviously a context where the V is not 64, yeah, because it selects the trivial path here, but where V is 128, yeah, so we have to enter here. But since V is 128 in our context, not 64, not 255, well, we are not allowed also to go into the output plus equal 1 case. So this now is a much more precise and also realistic worst case path, which can be executed also in the real execution. Yeah? All right, there are some updates in the TimeWeaver analyzer as well. Well, first of all, we support a new trace export format for the Lauterbach debugger. It's a so-called BRANCHFLOW format, and this is the export command in the Trace32 actually. This is also can also be found in our documentation. This new BRANCHFLOW format is much more compact and can be more efficiently be processed by the TimeWeaver trace parser. We would recommend to work with that format in the future. Okay, for the other feature, the new analysis start picker view, I'd like to show you that quickly in a demo. To create new TimeWeaver analysis items, you typically go to Analysis, Create, and click on TimeWeaver, right? And then there is this nice analysis start picker, which will load all symbols from the application's symbol file. In case of a TimeWeaver analysis, you can restrict that list by to show only those entries which are reachable in the trace file. This makes sense because otherwise you cannot select the entry point anyway. And now when you restrict it to these functions, you can see here also the new occurrence column, and it visualizes how often this function occurs over all trace files you need, read in as an input. You see, for instance, the func1 occurs 45 times in the trace file, so you have 45 different timing information, timestamps for the instructions in that function. So we could, for instance, use that one, okay, and say func1 and perform the analysis from there. No? Okay. Okay, now let's give you an update on our AS2 specification language. With this release, we are introducing new routine local user registers. You're probably familiar with the concept of the globally valid user registers with these user and then your own defined names. You could introduce values into the data flow of the value analysis, typically using the annotations here with the enter with. You said, okay, I'd like to introduce my name here variable with a certain initial value, and then you could refer to your username variable later in some other specifications. A little drawback is that these are globally used and they survive until the end of the analysis scope. Now, with this release, we also introduce routine local user registers. When you use local and the name instead of the user name, this variable will only be introduced local to the routine scope. And whenever you leave the routine's context, then the user variable name won't be available anymore. Here's some small example where you introduce a global register G1 and local L1 in the first instruction of routine R1, for instance. Next, new specifications are local value partitionings. So in our contradiction finder demo, before we used a value partitioning on the return value of the process sensor routine, you remember, for the register D2. This partitioning, this value partitioning, also had a global character. So whenever you started, from the point on you started partitioning, the analysis continues to perform all computations in these partitioned contexts, and they can no longer fold together anymore. With the so-called local value partitioning now, if you use that option, then the value partitioning is spanned within the actual routine only. This is very similar to when you use trace partitionings. They also just work within one specific routine scope. So here's another example. At certain instruction, at a certain program point, we would like to start a partitioning, but this time a local partitioning, where we want to spend two different contexts for the register R5, namely one where it is 3 and where it has the interval values 4 to 7. No? And when you leave the routine containing this instruction, then your contexts fall together again. And last but not least, we introduce a new global attribute in this release. It's the attribute core ID. This complements the other attributes, and you can check this core ID as well inside of the specification language. So it will especially read off the configured value in the project settings. So here's an example. When we have a project which is for the tri-core architecture, then we could check if we are doing an analysis item where the core ID was selected to be 0. Well, then I'd like to exclude code for which is core 1 and core 2 specific, right? So this can make sense to request the selected core ID option. All right, as usual, this was just a small selection of the new features for release 22.10. A complete list of all changes and improvements can be found on our webpage, www.absint.com/release notes. I hope you liked that release video. If you have any questions, feel free to mail at support@absint.com. Thank you very much for your interest. Take care and bye-bye.